Hi, good day. Welcome back to our class in Chemistry 102B. Today, I will be performing a pre-lab lecture on the activity, the analysis of group 4 cations. For the group 4 cations, this includes magnesium, barium, calcium, and strontium. We are going to apply in here a flame test as well as the precipitation test. So let's start with the analysis of the magnesium ion. So in analyzing the magnesium ion, we are going to add the magnesium chloride with ammonium carbonate first. So let's get some amount of the magnesium chloride and the ammonium carbonate. So to 1 ml of the magnesium chloride, let us add 2 drops of ammonium carbonate. The next procedure is we are going to add ammonium chloride and ammonium hydroxide to magnesium chloride, then ammonium carbonate. So let's get 4 drops of the ammonium chloride. This is ammonium chloride. Then let's add ammonium hydroxide.
Yeah.
Then add 1 ml of the magnesium chloride. And 2 drops of the ammonium carbonate. Okay, after mixing the ammonium chloride, the ammonium hydroxide, magnesium chloride, and the ammonium carbonate, let us add to this mixture 8 drops of diammonium orthophosphate. So this is the resulting mixture when the ammonium chloride was added with ammonium hydroxide, the magnesium chloride, and the ammonium carbonate. Then it was added with diammonium orthophosphate. I want you to observe. Now the next procedure is to have a flame test of the magnesium ion. We will use here the magnesium chloride solution. Hydrochloric acid. Since we are going to have a flame test of the magnesium ion, so we have again to clean our nichrome wire by dipping it into the hydrochloric acid and put it over the Bunsen flame until such time that the nichrome wire will not impart a different color aside from the flame. Okay. Test again. So it seems no more other color imparted. by the nichrome wire. So this is now ready to be used. So we're going to get the magnesium chloride solution and test this over the flame. So, magnesium chloride. Observe what's the color imparted by magnesium ion. Let's repeat. Then we're going to test the ion barium. Instead of magnesium chloride, this time we're going to use the barium chloride. So this time, let's get 1 ml of the barium chloride. Then let's add this with ammonium carbonate. Two drops. 1, 2. Observe what happens. So this time we will mix again the saturated ammonium chloride, the ammonium hydroxide, the barium chloride, and the ammonium carbonate. I want you to observe. Observe. 1, 2, 4. Ammonium. Can we just place it here? Then another one. Ammonium hydroxide. 1, 2. Then we're going to add barium chloride. I'll get barium chloride. Barium chloride and ammonium carbonate. This is ammonium carbonate. Observe what happens. Then, from this mixture, we're going to add diammonium orthophosphate. And I want you to observe what happens. Then we're going to have a flame test for barium ion. So we will clean again our nichrome wire for it to be prepared in analyzing for flame test the barium ion. So let's get some amount of the barium chloride. Kindly observe the color imparted by the barium ion. The next procedure is we're going to analyze the calcium ion. So let's get 1 ml of the calcium chloride. More calcium chloride. And let's add this with ammonium carbonate. 4 drops. 1, 2, 3. Observe what happens. Then we are going to mix the ammonium chloride, the ammonium hydroxide, the calcium chloride, and the ammonium carbonate. And I want you to observe. Observe what happens. This time, let's get a little amount of this mixture and then we will add it with diammonium orthophosphate. Observe what happens. So we have analyzed already the calcium ion. Then we're going to apply a flame test for calcium. Again, because we're going to apply the flame test, so we have to clean again our nichrome wire. So there is still the color of barium. Repeat until no more color of the barium is imparted. Repeat. Okay. Kindly observe the color of the calcium ion. So we are done analyzing the calcium ion. Let's go to the analysis of the strontium ion. So we are going to use here the strontium chloride. Let's get 1 ml of the strontium chloride. One more. Then we are going to add ammonium carbonate solution. 4 drops. 1, 2, 3, 4. Observe what happens. Then this time we are going to add the saturated ammonium chloride with ammonium hydroxide, the strontium chloride, and the ammonium carbonate. Saturated a little bit more. Then the ammonium hydroxide. The strontium chloride. And the ammonium carbonate. Observe what happens. Then we're going to get a little amount from this mixture and add it with the diammonium orthophosphate. Kindly observe what happens when the mixture of the saturated ammonium chloride, ammonium hydroxide, strontium chloride, and ammonium carbonate is being added with the diammonium orthophosphate. Then again, we are going to have a flame test for the strontium ion. So again, we have to clean the nichrome wire to prepare it for testing the strontium ion. Since the nichrome wire is not anymore imparting a different color aside from the color of the flame, so this is already ready for the flame test. Let's test the strontium ion. The next procedure is we're going to add to the different ions barium, magnesium, calcium, and strontium 4 drops of potassium chromate solution. And I want you to observe. So let's get 1 ml of these solutions. This is barium chloride. This is calcium chloride. And this is strontium chloride. And to each vial, we are going to add 4 drops of the potassium dichromate. And to each vial, we are going to add 4 drops of potassium chromate. Observe what happens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. 2, 3, 4. Remember, this is barium chloride. This is calcium chloride. And this is strontium chloride. Now, I want you to observe what happens. If you're going to think about it, that means you can tell which of the 4 ions of the group 4 cations can precipitate with potassium chromate. Then the same procedure is to be followed, but we are going to add first the acetic acid before we add the potassium chromate. So again, let's get the different ions. So, 1 ml of barium, 1 ml of calcium, and 1 ml of strontium. Before we add the potassium chromate, let us add first the acetic acid. Four drops. 1, 2, 3, 4. 1, 2, 3, 4. 4 drops. 1, 2, 3, 4. Okay. Acetic acid. Then we're going to add the potassium chromate. One, two, three, 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Observe what happens. So, from the result in 2D, this is the calcium chloride and this is the strontium chloride. Then we are going to add to this, let us add to this an equal volume of the alcohol. Double the height. Okay. This is the calcium and this is the strontium added with alcohol. Observe what happens. Strontium, calcium, so this is the strontium, which is added with ethyl alcohol, then placed into the water bath. Observe what happens. And this is the calcium added with the ethyl alcohol, then placed into the water bath. Observe. So this solution, which is actually calcium, did not form a precipitate, so let us proceed to procedure letter F. We will add this with ammonium oxalate, and I want you to observe. Let's add 5 drops of the ammonium oxalate. Observe what happens. So the calcium added with the ethyl alcohol, then heated over the water bath, and added with ammonium oxalate. This is the result. So this is the precipitate formed at the bottom. So I want you to observe the precipitate form at the bottom, and we're going to decant this solution. Having seen the precipitate, let us decant the liquid part. Then to the precipitate, we're going to add 5 drops of the hydrochloric acid. I want you to observe what happens. Observe what happens to the precipitate that you have found at the bottom of the test tube a while ago. What are you going to do next? What you are going to do next is you are going to write all the observations that you have made, and please answer all the questions given in the lab guide. With the output that you have made, kindly submit it next week. So that would be all for today. This is your teacher, Professor Ruiz of Holy Name University.